Hi, this is John Bock with Optiv Security. I work in the R&D group at Optiv, and one of the things we do is look at the marketplace for new products and technologies that can help enhance our customers' cybersecurity capabilities. So software composition analysis brings a lot to the application security or secure development program that you may have, but it can also help the vulnerability management side as well. So what we're going to talk about is how SCA can be directly integrated into vulnerability management programs, the types of issues you'll deal with both on the security and development side, and also ways to be more effective at that in the long run. So let's quickly run through the agenda for today. First off, we're going to cover the landscape just to get some background on what vulnerability management and application security looks like. We're going to do this really quick just to level set what types of programs we can be talking about, because it's a wide range between a modern and mature DevSecOps environment and a legacy organization still getting up to speed. We'll talk about a little bit about open source vulnerabilities, basically how they've interacted with vulnerability management since vulnerability management has been around. And then how these types of open source vulnerabilities that we're talking about today differ from the legacy types of open source vulns that a VM team may be used to. We'll also look at an example integration model that we have running in our lab, as well as triage workflows and basically how vulnerabilities that come out of an SCA both are similar to and have important differences what is usually managed inside a VM program. Finally, we'll turn to some proactive measures that you can take, basically ones that will allow you to minimize the impact of a SCA drive vulnerability while you're in production and help you be more agile in actually responding to them. Let's go through some quick background on vulnerability management and some of the concepts we're going to talk about in relation to SCA and AppSec. So at its most basic level, vulnerability management generally looks like this. We've got a discovery phase where we're figuring out which assets we have. We're scanning them with remote, agent-based, and other types of scans. Those scans are being fed into a triage process where we basically validate any false positives, look for prioritization opportunities, and basically figure out what needs to be fixed now and what can be deferred to later. Then we go through a remediation phase where we actually fix the vulnerabilities and validate those fixes. And finally, there's usually an analysis and reporting side where we're basically trying to derive metrics, see what's working and what's not, and figure out how we can be more effective going forward. So vulnerability management like this is a continuous cycle in a production environment, and the scope of that program also is the production environment. While we can have a similar process inside development, generally the goal is to make sure things are secure before they land into this ecosystem. So another way to also look at application security versus vuln management in a simplified form is to say that application security, secure development is focused on pre-production, basically making sure that whatever we're delivering to that production or live environment is actually secure. It has DAS, SAS, and SCA as its common toolchain, and testing ramps up closer to release. So what that means is it's very common to have continuous integration of, say, SAS in every build. But when we have major releases, the level of effort towards security testing will usually ramp up all the way to including manual penetration testing by a security consultant or employee to make sure that they're identifying all the vulnerabilities possible before it actually goes live. With vulnerability management, we have a focus of what's in production and what can actually impact the organization today. So when we talk about open source as a specific focus for CISOs, basically what we mean is the open source vulnerability awareness that's been driven over the last few years of high-profile breaches, with open source frameworks or tools being pointed to as the culprit. Now, current VM tools obviously find vulnerabilities in open source operating systems and services, but they don't have the context to identify vulnerabilities and application dependencies. Obviously, SCA gives that to us. So what we need to figure out is how SCA-like capabilities where SCA itself can be introduced into the vulnerability management side of the house. Now, there are some exceptions to that. So, for example, Snyk licensed its vulnerability database to a number of vulnerability management tools like Tenable and Rapid7 that, at least for things like container scanning, can enhance their capabilities to the point where they can get the same level of awareness. But it's not something that's ubiquitous to the whole market. So therefore, we have to look at how we can take SCA tools independent of what you're running inside VM and merge those two together from a program perspective. So to walk through this conversation, I want to give a couple simplified models of how to look at application security vulnerabilities that lend itself to a specifically vulnerability management style of discussion. So an easy way to think about applications is take each of these pie charts and think of them as application A, B, and C. And the types of vulnerabilities that in its most generic sense can break down into code, configuration, components, or dependencies. So basically, code is where 95% of the focus for application security is. So we're looking for vulnerabilities in code where we've got training to do secure coding to prevent vulnerabilities in code being introduced. When we're talking about remediation, most of the vulnerabilities are going to be in code. And so that's where the general time has been spent over the last 2 decades of AppSec. For configuration, the vulnerabilities there can change depending on what you're using. Generally, those are things that are found out early in development and before they go live. But if you're using a product that changes its feature set often, say like Kubernetes over the last 3 years, where they have a continual march of new security features and enhancement, your configuration may need to change even in a already deployed application, because now you can take advantage of new security mechanisms that are in place. And then components is basically what SCA covers. So all of the third-party dependencies, open source libraries, whatever you have to actually make up your application or product. Now, from a CISO perspective and from a vulnerability management or security program perspective, look at how long it would take to generally fix all of those different types of vulnerabilities, and also how you would discover those different types of vulnerabilities. So with code, that's usually going to be discovered through SAST and DAST, and without a degree of tuning or care in its actual running, you could run into false positive problems and other things that both the developers are used to from a headache perspective, as well as the security teams used to in terms of trying to hand over really high quality findings out of those products to them. Code also has generally a level of effort associated with fixing them, because it takes a human to correct those issues most of the time. And so if you talked about most application vulnerabilities that a security team or a CISO used to be dealing with over the past few years, it's going to be things that arrive from code. And so they know that, one, it may have been somewhat difficult to detect, and two, when they went to the development team to actually fix it, there was definitely a cost there in terms of taking time away from a sprint to actually fix these issues. Configuration vulnerabilities, much less so. It's usually more straightforward to detect. You know, the configuration setting is either on or off, or it's much easier to interpret. And then components, likewise, are pretty easy to interpret. You have a specifically vulnerable version of a dependency. If it's that version, then it's vulnerable and you need to address it in some way. So another thing to think about is how vulnerabilities change over time in a deployed application. So remember I talked about application assessment activity basically ramping up on a given application towards a major release. So consider like the top peak of application assessment activity a manual pen test. They're not having folks do manual pen test every single day out of every single new feature that's added outside of a small number of organizations. So generally what you'd have is, hey, we have a release, it's building up to that, we've got everything manual pen test, we have clean DAS and SAS scans, and then we're shipping it and it's live. Now, from the VM team's perspective, they may have gotten into a little bit of a false sense of security over time, thinking that, well, we tested this code when it was released, and while we know they're adding some incremental features and fixing things, we don't expect a lot of the code to have changed over time. So the risk from vulnerabilities being introduced to new code, at least for a lot of folks, is seen as minimal. It's not always true, but that's kind of the way it operates. But vulnerabilities over time, if you shipped an application and let's just pretend it doesn't change, well, there shouldn't be new vulnerabilities introduced by the code or config unless there's a new attack technique comes out or something else where, hey, someone's discovered a new way to exploit that particular language or framework. But generally speaking, code and config vulnerabilities, if you're not changing the code or config, you wouldn't expect new ones to just show up out of nowhere. With components, it doesn't matter if you've changed anything or not, because for all those open source components that you have in this application, even if you don't touch it for a year and introduce no code changes or config changes, those components will still have a potential for a vulnerability being introduced, multiplied by however many components you have. So there's a higher likelihood that even in a production application with no changes for a long duration, that you're going to have to deal with vulnerabilities from those vulnerable third-party dependencies and components. And so that awareness of, okay, you know, getting away from the default thinking of vulnerability management in terms of an application being good because we did a whole bunch of testing 6 months ago during that last major release, and we're hitting it with our regular vulnerability scanner every day along with everything else, that doesn't mean that you're actually addressing all of the issues that could be present inside that app. So also when we're thinking about vulnerability management, there's a lot of other ways it's expanding and has been expanding in the last few years. So standard features that you would expect out of a VM program now are looking at your cloud configuration for AWS and Azure. You're looking down into your containers, at least in some way. You're looking at your IAC Terraform code. And then if you've got any type of IoT, OT, or ICS presence, you're at least expanding that as it relates to your production environment. So VM is always going to have to follow any technologies that the organization is using because it needs to expand its assessment track to make sure it's adequately discovering all the assets and risks that may be present. So let's take a quick look at open source vulnerabilities that would come out of an SCA and talk about how we can present them to the vulnerability management team against a framework or standard that they are used to relating to. And then also how open source vulnerabilities have been kind of present inside vulnerability management in the vulnerability management space historically. So open source vulns have been around for as long as vulnerability management has been around. Generally, if we're talking about the types of open source vulnerabilities that a security team would be used to dealing with, they would be at the operating system and service level, or at the language or framework level, generally something that would be considered part of the server administrator's role or an ops role versus something that would be part of the application build package. So when we talk about the basic tenets of open source, ideas like the source code is available, that anybody can see it, that anyone can audit it and find bugs in it, and then if a patch is issued for a security vulnerability, you can see exactly how it's fixed. All the concepts that go along with open source are things vulnerability management teams are already used to dealing with. So there's not a need to walk them through those basic fundamental tenets of what open source actually means. Really, it's the fact that now application dependencies can be addressed in the same way all the other open source components of a package or a product were before. So there's a couple different things to think about in terms of how security looks at these vulns. So one of the things is that the major upside is that when we talk about explaining an application security vulnerability in code, like a deserialization vulnerability, to a room full of folks that may not have that development or application security background, which is pretty common for vulnerability management teams, something like an outdated library is much easier for everybody to process. So when, if we're dealing with a situation where the developers really are the ones that understand the internals and the vulnerability management team is kind of just dealing with risk and criticality scores, that ability to basically look at these types of vulns and say, okay, this side gets it, this side gets it, it tends to be something that everyone gravitates toward to as far as something they can work on because they actually understand it. The downside is that when you're talking about patching outdated components to a vulnerability management team, they understand that while there is risk involved in patching, they have ways to mitigate that in terms of limited distribution of that. Basically, they understand that while there is risk present, it's not necessarily going to break everything in the world or not break it in a way they can't recover from. So they may not understand that in the development world, while the remediation path is known, that you basically have to update to this latest version or the version that corrects the issue, that it also may break the build or other things involved. So when we get into these discussions with the vulnerability management team, it's important to level that out for them if they aren't already kind of aware of that fundamental concept. So when we think back to maybe one of those application pie charts where we have code config and component risk, when we look at dependency vulnerabilities, it's an awesome place where we can knock out a big chunk of risk. So if we're trying to figure out, okay, we have this many code vulnerabilities, what's the level of effort or how long it's going to take to fix them, that's not always something that's easy for the development team to actually give an estimate on. In terms of mechanically how long it takes to do something like update libraries, that's usually more predictable. Now, obviously, it could break the build and you have to go in and figure out what happened. But if we're just looking at, okay, how can we eliminate the largest chunk of risk that's present in an application, and theoretically the quickest amount of time, usually that will gravitate toward dependency vulnerabilities. And for CISOs, the major factor that they're running with these days is how to reduce remediation times. The wave of we need to detect more and assess more, that is pretty much topped out. And now the issue is that we've detected a whole lot of things, but we can't fix them quickly. So when we're looking at application vulns, that can definitely be the case, especially if there's major refactoring or architecture changes involved in needing to fix those vulns. But when we talk about dependency vulnerabilities, there's a greater chance that the way to actually remediate it may not require any changes at all. So a couple other things that are important too when we're a development organization, we're trying to interface with a security team. One is to know where they're looking for these vulnerabilities. So NVD and CVE are going to be the two primary sources for anything that comes out of these tools. Also the major kind of cross-reference for vulnerabilities in general. So if you're not already familiar with them, it's good to take some time just to dive in a little bit and understand how the NVD especially works in terms of digging through it for research information. MITRE ATT&CK and OWASP Top 10 are other things you'll probably be hearing about. OWASP Top 10, I would assume if you're a developer at this point that you are aware of it and you at least follow some of the tenets. MITRE ATT&CK is one you may not have experience with. It's generally more focused in the vulnerability management and cybersecurity side of the space, but we'll dive into that a little. And also CVSS risk scoring versus what's actually reachable or accessible in that application is probably the biggest major differentiator. So just to talk about CVSS really fast, here's an example of CVSS score that basically shows you how they're looking for vulnerabilities. So CVSS was designed to give vulnerability management teams a way to understand how much they need to prioritize a particular vulnerability and how much of a risk it actually is. And so they have a couple different components here. So attack vector, the complexity, what privileges are needed, if the user needs to do anything, and that's generally for something like a endpoint style attack where a user may have to click something through. And then other standard things like scope and CIA. The biggest thing here is that understand that when a SCA vulnerability or outdated component vulnerability comes up in that vulnerability management console, this is the type of information they have. They have information about the vulnerability, but they don't necessarily have information about the vulnerability inside your application. So they know that, okay, I have a thing that is vulnerable, but you as the developers are the ones who would have to determine if it's vulnerable and reachable. So in other words, does it actually exist in an exploitable state inside that application? OWASP, in terms of how we can basically say, here's what SCA covers from an OWASP top 10 perspective, that would be A9 using components with known vulnerabilities. Now, obviously, a outdated dependency or dependency vuln can have a vulnerability that falls into one of the other OWASP categories. But if you're in any type of mode where you basically have to show that your development processes are complying with OWASP top 10, say you've got a third-party assessment because you're trying to sell into a customer that requires it, and they want to see how you're covering all your bases here, SCA is going to be specifically how you would address A9 to an acceptable degree. So MITRE ATT&CK, and this is a bit of an eye chart, it's a matrix of different techniques that are used by attackers in the course and throughout a breach. And the goal here really is and used in a variety of different ways. The most common way is a planning tool. So imagine you're a CISO and you're designing a security program, and you need to make sure that you have a way to identify all of the different vulnerable states that could exist to allow exploitation or usage of one of these techniques. And you also want to make sure you have some defense that can detect them if attackers actually employing them against your org. So from there, again, obviously a vulnerable dependency could have implications inside multiple sets of techniques. But really, when we're talking about SCA and attack techniques itself, it breaks down into two specific categories. The first is going to be pre-attack. So that's generally all your reconnaissance activities. And so there they call out identifying vulnerabilities in third-party software and then enumerating any type of externally facing software or apps which does include dependencies. On the initial access side, exploiting a public-facing application through one of these vulnerable dependencies is going to obviously be the major one. And then supply chain compromises as well. And so what those factor into SCA and dependencies are basically, if you look at your dependency update process, and if you've got major glaring things like you're ignoring signing errors or any type of certification or crypto errors in that package that may be part of the actual verification chain, that's going to be something that can make you more open to supply chain vulnerabilities than you otherwise would be. So let's talk a little bit about an integration model with SCA and production VM and the things you need to look out for. So first off, as a base requirement, here's what we're trying to do. So we're assuming that SCA is running continuously in development, that developers are looking at those vulnerabilities and addressing them before it gets over into the live build. So we're also assuming that there may be some drift in between that in development version or build and what's actually in prod, which can extend from days to weeks to months. So what we need to figure out is how to make sure that the production environment has that same level of continuous SCA assessment being performed against it, and that any vulnerabilities are found from that SCA process get over into the production vulnerability management event handling. That can vary depending on how you have things set up. Generally speaking, if you can take your SCA output, group it appropriately so it's only looking at builds that are representative of what's in prod, and then send those over to a vulnerability management integration tool of some type, that will basically allow the vulnerability management team to only need to focus on those vulns that impact production without getting overloaded with the other vulnerabilities from your development process. So the expectation is that you may have DAS, SAST, SCA all running while you're doing development, and you're fixing all those vulns and everything. but you don't necessarily want the vulnerability management team to start paying attention to all that stuff because it doesn't affect the live environment that they're concerned with. So you want to get them these vulnerabilities, but you need to do it in a way that makes sure that you're not confusing them or having them spend time on things that don't affect the real world yet. So the other thing too is that when we're talking about a specific filtering function, it's almost always more ideal if you can do it on the SCA source side, or in this case, Snyk. Say set up another organization that looks at those builds, or something where you can separate out the focus for the vulnerability management team versus what the development team is looking at. So the example integration model we have running in our lab is using a product called VULN to hook everything together. So we basically have Tenable.io and some agents with Snyk, and then Chef, Puppet, ServiceNow, and Slack and Jira all running there. And the goal is to take vulnerabilities from Snyk, triage them inside VULN alongside vulnerabilities from Tenable, and then being able to redirect them as needed. So, ServiceNow is really common in the vulnerability management space with the vuln response module for managing that, while Jira is obviously more common on the development side. So it's important to look at whenever integrations you're doing, understand where you're doing each part of the workflow. So if you've got a vulnerability management integration tool and you're just using it to hook things together and reroute stuff through, say, ServiceNow, you have to make sure you're aware of that ticket, where that ticket goes in terms of determination versus where it would go if it was just managed inside that tool. So there's a few things to watch out for when you're managing those vulnerabilities. So duplicate vulnerabilities is probably the first one. So if you have a vulnerability that comes in, goes over to vulnerability management, the VM team says, yep, this needs to be fixed, kicks it over to dev, winds up in Jira. Well, if you've got Snyk or your SCA reporting right to Jira anyway to create issues based off stuff, you may have a duplicate issue there. So you want to make sure that you're adequately filtering those, or you're tagging them so you can actually pick up on duplicates when they occur. You also don't want to repeat analysis. So if you've got analysis that's being done on the security or the vulnerability management side, where they're kind of digging into the background of the vuln and giving you more specificity, you don't need to repeat that for every single occurrence of the vuln. So, I mean, if you have a common application stack and you have 20 different products, well, that dependency-related vuln is going to appear in all 20 of those. But the security research in terms of figuring out where the vulnerability actually exists only needs to be done once and shouldn't be repeated. So you should make sure as you're looking at that workflow that there's ways for folks to refer to other instances where that vulnerability has been updated and notes have been added. So now let's dive into that triage process and see what it looks like inside vulnerability management. So let's think about those SCA and dependency vulns from the perspective of that security team. The security team is going to have a score and a criticality coming from the tool. They'll basically look at something like exploitability, if it's actually reachable inside an application, as well as criticality for what the vulnerability actually is. So we have to remember from the development side, what the security team is looking at is purely the theoretical potential of that vulnerability. So when they're calling you and saying, hey, this is bad, super critical, we need an emergency change, realize they're working off the information they have in hand. So what we need to do is get them an answer back quickly if we're not going to go ahead and update it and react to that, of if it actually, what the actual impact is in reality. But there are some things the vulnerability management team can do before it sends that ticket or that issue over to the dev side. So the first thing is generally vulnerability research, and research in the way of trying to decode or decipher whatever advisory or notification has been sent out by that open source project that gets to as much specificity about the vulnerability as possible. So it's not generally helpful if it just says there was a vulnerability in this particular library and that's all the information you get. If you're just working with that, then you really don't have a choice other than to evaluate where that library is being used. If you can narrow it down to a specific feature or function in that library, then hey, that gives you a little bit more of a specific thing to hone in on and save some time. The other thing too is that open source projects, well large funded ones can have really great security documentation standards and advisory standards and everything else. You may also be using a component that is just written by someone in their spare time, and they may not even send out a notification for a security vulnerability. They may just fix it and call it a day. So what you can do is, without spending a ton of time on each one, dig into the advisory a little bit, see if you could pull out anything specifically about what the vulnerability affects. If it's open source, we generally assume that a lot of the issue or defect tracking is going to be open source as well. So if you can dive in there and get any more security-related information, maybe from a mailing list, changelog, whatever, that can help that developer get to that answer more quickly. And then even dig into the issue tracking and give them some pointers. So if they wanted to go take a look at specifically what was changed, all that is queued up and ready for them to go. So they can basically just consume that enrichment immediately and get onto their task, which is figuring out if it's actually affected in the app. And from the dev side, when we're applying to the VM team, let's try to break it down into pretty simple statements for them. So the big one is if it's actually in use or not. So you could have a library or a dependency in the build that maybe isn't really being used, or was kind of left over, or it's not being used by any active code. Maybe it was used by some like internal test harness or something that just isn't being touched anymore. So if you can get that answer back quickly, then that is going to help reduce the heat level from the vulnerability management side. If it's actually in use, is it reachable externally? Is this something that user-facing data from the outside could actually get to and then actually potentially exploit? And if it is reachable, try to break it down into a really simplified access model of anonymous, a user level account, or the most general user level access you have. And if it's a specific user group like admins, relay that as well. Because a vulnerability that can be affected or by anyone anonymously connecting to the app or service is going to be more of a problem than one that is only really effective by 3 people who are in an admin group and accessing some internal panel of some type. So for our triage process, we're basically breaking down into 4 easy phases. One is security research, where we talk about vulnerability management and enrichment. So that's where the VM team goes in and digs up everything they can from a security perspective about that vuln, gets it all teed up for the development team to dig into. The development research side, where they're giving an answer back to the security team, which is basically, is it in use? What's the impact? Do we really have to worry about this now or later? Prioritization, when we want to fix this vulnerability eventually, even if it's not in necessarily a critical place right now. So what's going to be the priority? Can this wait till the next big change window? Do we need to fix it now? All those things that from our security and development research, we're going to be able to come to an answer on. And then remediation, finally, when we actually fix it, when that push is actually deployed to production, when it's pushed to the backlog in a place where it's going to get assigned in some sprint and dealt with. So now let's talk about some proactive measures you can take when dealing with SCA-related vulnerabilities. So first thing you should do is make sure you have a response drill down or know what to do when an SCA vulnerability comes in from your live environment. So typically, if you're dealing with application vulnerability, say from a bug bounty that came in or an external pen test, you know how to treat a vulnerability when it's in code. You have a process for evaluating that, determining what needs to change, and actually running the change through. For dependencies, it can be slightly different. If you decide to accept all of those potential upgrades and just do them, that's one thing. If you need to balance it out based on your budgeting, there are some answers you need to arrive at, and determining how it's in use and where it's being used and what level of access was required can be kind of important. The other thing to think about too is if a dependency-related vulnerability is found, if it wasn't found exactly the same day that the vulnerability was released, someone may have exploited it. So understanding if it was actually in an exploitable state in your application can be kind of critical, because if it was, you'd want to look for evidence of other attacks. The other thing too is to make that repeatable. So when we're talking about something being part of your incident response documentation, that means that everybody on the team needs to understand how those processes work and those tasks work in relation to the development tools that you have in-house. So doing things like determining where a particular function is in use in your code base can vary depending on what you're actually using. So you need to work through that and make sure everyone is comfortable doing it and it's something that's documented. Secondarily, if you can actually push those tools to the VM team, that's a great thing. Not necessarily every vulnerability management team is going to have development or application security skills, but if they do, don't be worried about sending those tools their way. When it comes to sprint planning, another thing to look at is your security maintenance that you're budgeting per sprint. So obviously, if we're talking about vulnerabilities that center around things being out of date and particular components being out of date, keeping them up to date on a per sprint basis or regular basis is something that can help mitigate that. Now, obviously, you may run into situations where it's breaking the build, but theoretically, when you're dealing with security maintenance on an ongoing basis, those breaks are going to be smaller events than if you had deferred all of that and waited until you ran into an actual live incident. And now you may be dealing with multiple components that need to be updated, maybe dealing with a very large version jump in those particular dependencies. So the chances of a lot of breaks being introduced from that large leap is going to be greater than being able to say we're budgeting for a fixed amount of time on a regular basis in a more consistent way. So to close things out, we have 3 major points here. 1, take a look at your SCA now and see if you can engage with vulnerability management specifically if there's any gaps in between what is present in a production environment and what the VM team actually sees from a dependency vulnerability perspective. Make sure SCA vulns have unique treatment or at least unique awareness on each side, both from the vulnerability management team and how they can evaluate them. Make sure that they understand that the criticality level doesn't mean it's necessarily exploitable all the time. Make sure the development team understands how to get those answers back to the dev team as quickly as possible. And then when you can, get preventative. So that means the more things are up to date, the less you'll have to worry about these types of situations. And making sure that if there is an event, that everybody knows how to react to it as effectively as possible. So I think we have some time for questions if anyone has any.